Welcome to solverfy.
For question number 54, we have the terrifying sci-fi-esque situation of a large, maybe, insect that is being projected through a lens. And given the object distance and focal length, we want to find the image distance and the magnification, if any, of this lens. So I will say right away, we don't necessarily we don't need to find the magnification, but we are going to use this to figure out how high the image is. So this is insect or object, and this is image. Well, the way to calculate this is pretty simple. We're going to be using the 23-8 and 23-9 equations. And for the first bit, it is something that is fairly familiar, I think. Our lens maker equation, as it's called. And you can rearrange this to get the formula for the image distance, which is going to be your object distance times the focal length divided by object distance minus focal length. And if you calculate this, you get that it is 0.1506 meters. So about 151 millimeters, maybe more appropriate scale distance here. And we want to find how high the image is and what type it is. And so to figure out how high it is, we can use the relation for the magnification, which is h image over h object. But this is equal to the negative of d image over d object. So using that relation, we can rearrange for our hi to get minus di over do times ho, and that is equal to minus 0.278 centimeters, which is similar in scale. Well, sorry, it's much smaller than the original height, but we kept it in centimeters as a point of comparison. So then, what kind of image is this? Well, it is real. The height is negative of the image, so it is going to be inverted. And finally, it is reduced. It is much smaller than the original. So for part B, we're going to do the exact same thing, except we're going to plug in a new f. So I'm going to start a new page here. You can go back in the video to see the old work. And let's pick a good color here. So just writing pretty much what we had already found. You plug in for the new focal length, which is minus 135 millimeters, which is a good sign that this is going to be a virtual image, but let's not get ahead of ourselves. And the distance is minus 0.1223 meters, or minus 122 millimeters. And finally, if we want to know the height of this virtual image, now we're really sure that's what it is, we do the exact same thing. I'll just skip ahead to the HI and working this out, get that it's 0.226 centimeters. So what kind of image is this? Well, the image is in front of the lens at a distance of 122 millimeters, and it is virtual, upright, because the height is positive, and reduced still, because it is smaller than the original.